Hi, my name is Paco Nathan, and I'm really looking forward to this masterclass about graph-based data science. The gist of what we'll be covering in this course is integration of a number of different kinds of graph-based techniques and approaches into popular approaches for data science. So we'll be looking at using semantic technologies, looking at probabilistic graphs, looking at deep learning with embedding, and other areas of graph algorithms, but then making them work fluently with your typical data science tools such as pandas, scikit-learn, NumPy, etc. And as well, we'll be very mindful about how to be efficient with distributed systems and big data infrastructure. So for instance, using Parquet and Arrow, integrating with NVIDIA Rapids for GPU acceleration, being able to integrate with Spark and Ray, etc. A lot of this is driving toward the notion of hybrid AI approaches. That is to say, how can we take machine learning models trained on lots of data, but then also combine them with more symbolic, semantic, rule-based approaches, such as probabilistic graph inference, knowledge graph embedding, doing shape constraints, auditing rules, things like that. There's a lot to be gained by having these complementary methods augment each other within your data science workflows. We'll be focusing on an integration library called kglab that works in Python. It works with a number of different popular graph libraries. We've got a bunch of materials here and developer forums, etc. But again, driving toward this notion of hybrid AI. And the integration is very rich. There's a number of different areas. I'm very excited. We've just completed some of the Rapids integration work with NVIDIA. We're doing a lot of work with PyTorch and other areas of deep learning right now, as well as integration into some of the popular graph databases. One thing I'd like to show is that this tutorial will be very much about hands-on, working with code. The expectation is you've got some Python background. If you can read and write 20 lines of Python, you're probably good to go. It will be helpful to have some of the math background, certainly like high school algebra level, but familiarity also just with working with data science. Here's an example of one of the notebooks we'll be using. This shows how to take a graph that's been built out of a CSV file. We're working with a large recipe data set. Take CSV data very simply, bring it into pandas, build a graph out of it, build an RDF graph with RDFlib, and then from there being able to do queries to be able to pull out sections of that graph, drop them into a matrix, and start doing graph algorithms with NetworkX on them. So from there, we can start, for instance, measuring some data quality or starting to see where are outliers. We can also go in and do some graph algorithms to measure and perhaps see if there are other issues in the graph or some interesting things that we could leverage downstream in our machine learning models. So we'll do some visualization, some annotation based on that. And again, this idea is being able to, like I say, mix and match between these different areas to build up much more powerful applications. Again, my name is Paco Nathan. I'll be your instructor, and I'm really looking forward to meeting you through the masterclass.